Welcome to Simply AI, a place where I explain all the complex and treated AI concept in a simplified and easy to understand manner. So in this session, we are going to learn how to predict your overfare. Here we are going to use the linear regression for predicting, the overfare prices. Now, linear regression is not the best algorithm to do so. There are other algorithms, right, like SVM or random forest, and probably those are the far better than the linear regression. But since we have learned just about the linear regression, we will see how we will, implement the same problem in a linear regression. Later on, we will try the same problem statement for those algorithms as well, and then we will compare the model. Okay, so I'm using this overfare dataset, which is from the Kaggle, to implement our machine learning model. I will provide the link of the dataset in the video description, so you guys can download the dataset from there. So here, if you will see in Kaggle, the objective is to understand the dataset and clean up, build regression models, and predict the fair price of overrides. Also, evaluate the models. So the third point we are not going to do right now. Once we will learn about the other techniques also, like the decision trees, and there are so many other algorithms. Once we will learn those algorithms, we will try to predict from those algorithms also, and then we will compare the models, like which one is the best. So I have already downloaded this data set. So let's see how will we proceed. So I'm going to create a new file, which is overfare prediction. Now let's import all the libraries. Now the second thing, I have this data here, over.csv. If you will see here, it does not make a lot of sense because it's just a raw CSV file. So we are going to use the Panda to read this CSV file and get some insight about it. Okay, so the one thing, there are a few things like the panda.read CSV and df.head. I have already discussed about these terms in our previous videos. So if you guys are not able to understand that, you can go and take a look to my previous videos. So we need to do the data cleanup. So I'm not going to go deep into data cleanup and data visualization because that's not our objective is. But I will do the few uh, data cleanup things and data visualization things so that you will get the idea what does data cleanup mean. So if you will see here, right, the for us the pick up longitude and pick up latitude or drop off longitude and latitude doesn't make any sense. So I think the better way to get that is to get distance. So it's like we have traveled 5 kilometers and this is what we paid. So the distance is something we want to calculate. So for calculating distance, we have the longitude and latitude. So we can calculate the distance of two longitude and latitude point. And we'll create one new column, which will display the distance of the right. Similarly, the pickup date time, which is like, suppose this is 2015 0507. Uh, if we will do any operation, doing operation in date time is a little, I mean, hectic. You will get so many errors, right? I mean, when you are doing the dot product or something, you cannot, do the dot product of date time, right? So probably you can, convert it to the month, year, and day instead of, having a date time. So this is how we are going to, to change our data. And once our data is prepared, we'll visualize this data and we'll see whether everything looks fine or we need to eliminate few rows. So when I'm talking about the eliminate few rows, I think we will see this later why we are going to eliminate few rows. Now, one command which we can use to get information about all the column is called the df.info. It will give you the information about all the columns. So here the first column is the unnamed, there is no column value and it's integer type. Then there are the 8 columns and each has the some type. So suppose the state time has the object type and others are float and this one is the integer. So df.info is a very useful to check which data type you have and what do you want to convert into. Let's check whether we have everything at place or not. So I have already written the code, so I'm just going to copy from there and paste it. So data processing and cleaning. So the first thing is the checking the null values. Why checking the null values? Because if you have null values in rows and you are going to do mathematical operation, it is going to make multiple null values. So based on that, your gradient might get null, and it's like everywhere we are going to do the matrix operation, right? So we need to eliminate those null values. So we are going to use is na uh, df dot is na, which will find whether there is any null values in the matrix or not. So suppose this is the your data frame and there is one np dot nan, and you are just going to do the is na. It will return the true false matrix. False means there is no null values, and true means there is some null values. So this is how you are going to check. So what we are going to do, we are going to do df dot is na, and then we are going to use the sum, which will sum the values. So if some of that values is null, right, then we will say there is null values in matrix. So first we are going to do the sum of all the the all the rows, and then we are going to do the sum of all the columns. So if variance is equal to 0, then we will say there are no null values, and if it is not equal to 0, we will say there is null values in data set and the count of that null values. There are two null values in data set, and the last two lines where we are replacing null values by mean and median values. So we already the know or mean, right? Or we can just do the df dot column name and then the mean value of that. So wherever it is null, because if it is null in drop of latitude or drop of longitude, and in place is true, like if the is na is true, we are going to replace it by the mean, and we are going and the longitude we are going to replace it by median. You can do the opposite also. I mean, or you can replace both by mean. So it does not make any difference. So this is how we clean up the data. We check for the null values because null values are not good, and then we replace those null values by mean or median. Okay, so I executed again the same line of code, and now we are getting there are no null values in data set because here we have replaced it by mean values. Okay, so now our next task is to you know look at our pickup date time, which is object time. So the first thing we are going to do, we are going to convert this object into date time. Okay, so change the incorrect data type. So we'll use the pd dot to date time to convert this column data type from object to date time. Okay, other than info, this is taking some time because it has a lot of rows. Now, if you will see, other than info, we have the d types also, which is going to return the data type of the your columns. So let's just wait for some more time and let's see what it is returning. Okay, it's done. So if you will see now, your pickup date time is the date time. So we will extract time feature from date time. So what we are going to do, we are going to create the new columns, and we will use the assign to assign the new columns. We'll create new columns like hour, day, month, year, and day of week. So why day of week? Day of week is very important because there might be a possibility that on weekends the fare is high and on weekdays fare is not that much high, right? So that is why the day of week is the one of the important column which we have. And again, if you will see, the dd dot r is also is very important because there might be possibility that the evening hours or the night hours the Uber fare is high, and the morning hours our Uber fares are not high. So that's why these columns are important, and we are going to get these columns from our pickup date time. Okay, now let's check how our data looks like. Okay, so if we will see, we have added few columns here, which is like hour, day, month, year, and day of week. So day is nothing, it's just a day, and then month. R is very important because that R is going to decide whether we have booked in the night hours or evening hours or day hours. So you know that is going to impact our fare also, right? So R uh, and day of week are one of the important columns. So the next task is to find out the distance which we have traveled. So we have the the pickup longitude, latitude, and drop off longitude and latitude. Now, how are we going to find the the distance between these two longitude and latitude point? So what we are going to do, we're just going to do the Google search, find the distance between two latitude and longitude point. Let's see here. Okay. So this is the Haber-Sign formula, which we use to find out you know, the distance between two longitude and latitude. So you can just go through this formula, or you can use the NumPy to implement this formula in Python. Since I have already wrote the code for this, I'm just going to copy from there and going to paste it here. So I'm using here the math because we are going to use the cos and sine, and there are other mathematical terms, and that's why the math library provides the access of all those mathematical operations. So I'm just going to use the those operations. So it's very simple. Here we are passing the longitude, latitude, the first, and then longitude, latitude second, and then what we are going to do, we are just mapping it, and then we are finding out the distance longitude and distance latitude, and then we are implementing our formula, which is this one: sine square del phi by 2 plus cos phi into cos phi into sine square phi by 2. So if you will see this, you can, I think, easily correlate with that formula. Okay, so let's create the new column, which is the distance travel kilometer, and I'm just going to the pass the pickup longitude to numpy, and because here we are going to do all the numpy operations, so I'm just taking the pickup longitude, the complete the column, and converting it to numpy and passing it to um, this function. So now again, let's check the df.head. Okay, so if you will see, we have the distance travel kilometer, which is the this, and here we can see it's showing the numbers, which is the distance we have traveled. Okay, so I think our data looks good. We have the extracted value from the pickup date time, and then we calculated our distance. Now let's remove the few unused columns. Okay, so I'm just going to drop the key and unnamed zero and the pickup date time. Okay, this is our final data. So you can see, we have done the data cleanup. So this is what data cleanup looks like, and this is how we do the data cleanup. Sometimes you get much more complex data than this, and then you need to figure out how are you going to save your data, how are you going to perform the cleanup. And sometimes what happens, you just do your cleanup things, and after then you implement the model and you get some error, and then you realize, okay, this cannot work. You need to clean the data more, or in a way, so that you don't get any error in the model. Okay, so I pasted this few lines of code. The first line, I think you guys all know, we are going to implement, or we are going to do every mathematical operation in NumPy. So we will just pass this data into np.array, which will convert this from data frame to NumPy and dimensional array. And then we are just printing out the the type of the data and what is the shape of the data. Here, now we are taking only 300 columns because we are using the plot to to visualize the data, and we are taking just one uh, input axis and one output axis. So if you will see, output is the first column, which is the fare amount, and then the this plot is the last column, which is the distance. So if you will see, we have some 200k, the data. We are just going to take 300 and we are just mapping 300. But so our x-axis is what our x-axis is distance we traveled, and our y-axis is the price. So if you will see, we have traveled more distance, the price of fare is getting increased. But as you can see, there are few points like this, right? So it's like the travel distance is around 0, but the fare is much more than the travel distance of 20 kilometers. So these data are clearly are invalid data, right? So I'm not going to perform the cleanup on these data, but your next task might be to eliminate this kind of data, because this data is going to affect your model. So your best fit line will be this, right? But because of this data, your line will get deviated from actual data set, and it will go a little bit like this. So one thing, since we have calculated the distance, the longitude and latitudes are not needed. So we can, delete the sixth and seventh column also. And now if you will see the total number of, the input, say, which is some 20,000 by 9, and sorry, 200k by 9, and then, output is 200 by 1, which is the our fare. So this is the first column, and this are the other columns. Now, this is a feature normalize function, and it's exactly the same what we have learned in our previous session when we implemented linear regression, right? So we are just calculating the the mean and the standard deviation, and then we are getting our the normalized input matrix. Why are we using this formula? If you want to know, you can just watch my previous videos. I will provide the link in the below description, and you can watch it. I'm not going to discuss this again here. So this is the feature normalize, and we want to normalize our data. So I'm just going to pass our input matrix to this feature normalize function, and I'm going to get the normalized input and the value of mu and sigma. Why value of mu and sigma? Because we are going to use those values at the time of prediction. Now let's just uh, get some theta, which is just the 0 value, and the shape is going to the whatever the input dot shape 1, right? The number of features we have, we are going to take the theta, same as the number of features. So if you see, this is our theta. So we are using the value of theta, which is our initial hypothesis. So you can say, if we are drawing the our initial hypothesis here, this is how it looks like. Okay, so let's move on to our main code, which is now I think two things are left. One is write a cost function, and then write a gradient descent algorithm. So cost function or loss function, I have already written it. I'm just going to copy and paste it here. So this is a loss function, which is taking the input and output theta. We are just going to do input theta, which is theta transpose x minus output. This is our hypothesis, and what we are going to do, we are going to calculate a squared loss, and we're just returning the squared loss. So execute this 1113. This is our the initial uh, the initial loss, you can say. Now let's just train our theta and try to minimize our loss. Okay, so in our previous linear regression session, uh, this was what we have written our gradient descent algorithm, and this time also we are going to use same. There is no difference, right? We are doing the gradient descent, and we have some theta, initial theta, and we are just going to do theta equals to theta minus alpha into gradient. So I just copied that code and pasted here. This is the number of times we are going to iterate this, and gradient descent, we are taking input value, output value, and we are going to iterate this. Here we are just going to print our loss each time. So just to see the loss is getting decreased or not. And this is how we are calculating our new theta. So let's run this and check out whether our loss is getting decreased or not. Okay, so final loss is for 48 point something. We just ran the 999, and this is our final theta. So like that, you can play with the this parameter. You can play with the number of times you are going to perform this. You're going to play with the uh, the learning rate. You can tune your data, you can clean up your data, and just see that your model is working fine, your model is getting trained. This is plot our same data. Let's see. Okay, so this is our trained hypothesis. This does not look like the best fit line, right? Because there are other features also. So this is not the only features we have trained for. There are other features also which are contributed to get this line. And the other things are, if you would have remember, there were few data which was very far. So that data is trying to pull this line from their side. So once we will eliminate those data and train our model, we might get the better model than this. But this is how we train our model, and this is how we can predict our Uber fare. Now this is not the best way to go for it. There are other algorithms like random forest and SVM. We are going to use those algorithms for the same problem statement, and then we will just compare this model and that. So like there are few models which handles the noise by itself. You do not need to clean those noises from your data. So those models are those models are kind of the the better models than this, because they have the capabilities of handling the noise way more better than the linear regression. um, in our last set of code, we are just going to write the predict price function, which will use the and sigma and the input data which we are going to pass, and our new theta to predict the value. So this is exactly same. I did not change even any line of code. This is exactly same as our previous session. So yeah, I think that's it for now. If you guys have any question or queries, you can comment it down. I will love to answer those. And if you want more content like this, you can like, share, and subscribe my channel. And the next video is going to about the the probabilistic approach and how that approach is going to solve the this noise things. I'm going to describe it in our next session. Thank you very much for watching this. Please like, share, and subscribe.